it's an illusion that we can stop global warming. We already crossed the point of no return. We are just can slow down the global warming, but we cannot really stop it. Another very, very important thing is the illusion that the people can keep up their lifestyle. This is just not possible. Every one of us has to downgrade their life. And this is what especially, the rich kids, or not the rich kids, the rich parents don't want to do. Because at this point they say, it's not so important for me right now. It's more important to me that I can fly to a holiday than the climate in 20 years. And we are already living in this changed world. Climate change is hurting us right now, right today, and we don't have to think of the next 50 years. We have to be aware that the consequences of climate change are happening today already. So if you save carbon emissions and take climate action, you do it also for your own life, even if you're 40 or 50, because it could happen that in 10 years or 20 years, another heat wave hits you when you're 60 and you're just not strong enough to survive this. Climate change is already here.
Scientists for Future were founded in support of the Fridays for Future movement, a youth organization that demands the adherence to the Paris Agreement. The agreement is to pursue limiting the increase of the planet's average global temperature to 1.5 centigrade above pre-industrial levels. Unfortunately, we have already increased the planet's temperature by 1.2 centigrade, and we are on course to reach 1.5 centigrade within this decade. Scientists for Future organize science communication, fact-checking and consulting for policymakers, and they critique the policies that are being implemented. It is a model organization for scientists playing their roles in society. So I decided to make a series to feature members of Scientists for Future. We learn about their scientific background, their motivation, their activism, and their vision. In this episode, we talk about the history of global climate, science communication, and the responsibilities of the rich. Thank you to my supporters on Patreon. Your contribution is of great help. I am your host, Dennis Eckmeyer, and you're listening to episode 54 of Science for Societal Progress.
My name is Maria-Elena Vorrath, and I am a scientist at the Alfred Wegener Institute in Bremerhaven in Germany. My research is the climate history in Antarctica, especially the sea ice around the Antarctic continent.
So how did you get into climate science?
I studied geosciences in Hamburg. And from the second semester on, I was impressed by how the Earth system is influenced by all the different kinds of the climate system, especially how the chemicals influence the atmosphere. So carbon dioxide and methane and all this. And during university time, we did not really learn much about the current climate situation. We learned how the climate evolved over millions of years and how tectonics are working and stuff. But what is happening today, we did not really focus on. And when I applied for my PhD position at the Alfred Wegener Institute, I was very lucky to work in a polar region.
Lucky in the sense that the polar regions are the scientifically most interesting regions for a climate scientist. Temperatures there are rising quicker than anywhere else.
So the region where I work, actually, it's the Antarctic Peninsula. So the northern part, pointing towards South America, is my study area. And there you have a rise of atmospheric temperature from about 4 degrees right now.
Wow.
And the global temperature has risen about 1.2 degrees right now.
Now, this is concerning, and it's obviously affecting life in Antarctica. Elena mentions that new species are settling on the peninsula that couldn't survive there, including a fly species unintendedly brought there by humans. But as a geologist, Elena's professional interest in the ecology of Antarctica is rather practical.
To do climate projections, we need data from the past to know how natural systems react to climate change.
Mm-hmm.
Therefore, I do the basic research that other scientists can do their climate projections for the future.
And that's not as easy as it sounds. Getting to the samples is challenging. Her cruise to Antarctica took 2 months, including the flight to South Africa and 3 weeks at sea just to get to her sampling site and back. At the site, she collected sediment layers from the ocean floor.
There are algae living under the sea ice, and they produce a very specific molecule, which is like a fingerprint from these species. And if they die and sink down to the ocean floor, and if I want to reconstruct the development of sea ice in Antarctica, I just have to look on these molecules.
And that's not as easy as it sounds. Getting to the samples is challenging. Her cruise to Antarctica took 2 months, including the flight to South Africa and 3 weeks at sea just to get to her sampling site and back. At the site, she collected sediment layers from the ocean floor. So how deep do you have to go to get to your samples? I mean, first through the water and then how deep into the surface?
So the shallowest was about 200 meters or something.
Okay. So that I would call that pretty deep.
Yeah. So you can definitely not dive there. Yeah.
Right.
People ask me, oh, then you dive and collect your climate samples. No, never. Of course, if you work in other environments close to the coast, you sometimes just have 30 meters or something if you work in the North Sea or something. And I think the deepest we had was maybe 2,000 meters or something.
Oh, wow. Okay.
Yeah. But I was also on other cruises where we took samples not from the ocean floor, but from the water. And there we went down about 5,000 meters.
Mm-hmm.
Yeah. So it's possible.
Wow. You send down some sort of machine that digs into the ground?
It's a tube. You can imagine this like a straw. You dip the straw into yogurt, and if you put it out, there is some yogurt inside the straw, and this is how it works. So we put this tube into the ocean floor, the sediment, and we just pull it out again, and there it is. And we have two different kinds of sampling gear. One is a very long one, and you can get up to 5 or 10 meters of a sediment core.
Oh, wow.
Yeah, without drilling. It's just the weight of the gear. Mm-hmm. So there is some weight on it, and it's just sinking down by the weight.
Mm-hmm.
So we only can sample ocean floor, which is not very solid.
Yeah.
Yeah. And the other gear we use is a short corer, and it's going down 30 centimeters or something, 30 or 40. And there we can take 12 in one cast.
Ah, so, okay.
Yeah, so there are 12 tubes, and then we just put it down and lift it up, and yeah.
Yeah. Okay, cool. So how deep do you have to dig to get your, what was it, 17,000 years?
17,000. I found 17,000 in 10 meters depth. Yeah.
So you put a tube 10 meters deep into the ground?
Yeah.
Okay, wow. Cool.
Yeah, so I think the core was about 15 meters long, but it was disturbed. So in the lower part of the sediment was disturbed. And we always wanted to be layered without any interruption. And so we decided, okay, until 10 meters, it's fine, but below this, there is some disturbance.
So this technique gives Elena access to the different layers of sediment. Since sedimentation changes with seasons, these layers correspond with years.
I found different amounts of these molecules in different depths. And I was also looking at other molecules, which, for example, indicate an open ocean environment or the temperature of the water. And so I combined many different indicators of the environmental conditions to put together a picture of how the climate was 17,000 years ago, 12,000 years ago, 8,000 years ago. I just could go back 17,000 years, which is not much, but this is the time where the last ice age ended and we had a very rapid warming.
And that's how Elena established and evaluated this new tracer of sea ice occurrence for her PhD thesis, which she defended a few weeks before this episode was released. Congratulations! Okay, so Elena is an expert for climate change history. Her own data reaches back to the end of the last ice age, the last rapid global warming we know of. Back then, it took several thousand years for global temperatures to rise by 4 degrees. What is happening right now?
So my study area is warming very rapidly. And this also happens in the Arctic, of course. And in the Arctic, you have all these permafrost in Canada and Russia. And there you can also see that it's thawing a lot and it's burning. And you can see huge, huge impacts of this warming. So the ice sheet in Greenland, but also the ice sheet in Antarctica, they are also changing a lot. They melt. And you can also see that there is lots of fresh, cold water going into the ocean, for example. So the ice sheet is consisting of sweet water, of rainwater, but the ocean is salty. Yeah. And if you go there and measure it, you can see, oh my God, it's all fresh water. It's all melted ice sheet.
Oh, wow.
Yeah. And one of the most threatening facts is ice sheets. They sit on land and they slide very slowly into the ocean because it behaves like a cookie dough. So they slide very, very slow. The pressure of the ice is so huge that the base of the ice sheet is melting, and then you have a small film of water, and it's sliding slowly to lower levels on land. You can also observe the same with glaciers in the Alps. So the glaciers are sliding very slowly down to the valley. Yes, and especially in Western Antarctica, these glaciers end in the ocean. So they are in touch with the ocean. And when the ocean is warming, it melts the bases of these ice sheets. And from this, they slide to the water faster than before. And so as long as there is enough snow falling in Antarctica, this is in balance, but it doesn't. So the Antarctica and also Greenland is losing lots of ice. And the ice which was on land is now in the ocean, which causes sea level rise. And if you consider that Greenland would melt completely, we have a sea level rise between 6 or 8 meters. And if you consider Antarctica to melt completely, we would have something between 50 and 70 meters.
Wow.
And the good news is this doesn't happen overnight, but may happen that it becomes an unstoppable mechanism and that we cannot stop it for the next few thousand years. And it will happen in the next few thousand years. And I mean, 1,000 years is far away from our time now, but even 20 or 30 centimeters of sea level rise has an impact. This is likely to happen.
And the rising sea levels are also already impacting human lives.
The Pacific Islands, especially, they are very, very flat and they get directly threatened by this because with the rising sea level, you also have higher damages from floods and storms, for example. Also, your groundwater, when you're living at the coast, can get salty because the seawater is pushing into the land. And I think about 40% or something of the humans are living close to the coast. And also 8 of the 10 biggest metropoles on Earth are at the coast. There was this example from Jakarta. And Jakarta is a very special case because they take out lots of groundwater and they build lots of buildings. So they compress the land of close to the coast. But additionally to this, they also have severe problems with the rising sea level. And they just built a wall between the city and the sea.
Right.
And now they decided that they will move to Borneo. And I think this will end up as usual. The rich people will move and build a nice house, and the poor ones are left behind. And so this is the impact of sea level. But after all, sea level is very, very slow. And other impacts of global warming, like the warming itself or the the amplification of storms and all these things, these are things that happen faster and are that we also recognize these things much more than sea level rise.
Some scientists estimate that we've already triggered so-called tipping points. The metaphor is that global warming was like a finger pushing on the first of many dominoes that represent mechanisms destructive to the environment. Once the first domino is pushed hard enough, its tipping point is reached and it will fall, triggering a cascade of negative effects that accelerate global heating and cannot be stopped. So if we already reached the tipping points, is climate action a lost cause?
Fighting climate change, or as I say, avoiding more warming, is never a lost case, because with every 0.1 degree of warming, the damages on ecosystem and civilization and all this rise. And it is not a linear effect, it's more an exponential effect.
Mm-hmm.
So everything of warming you can avoid is a very, very big advantage. Just to inform you, our predictions on our business as usual are between 3 and 5 degrees for the year 2100. And if we can avoid 3 degrees and aim to 2 degrees, this would have amazing impacts. It will definitely be a very bad situation, but it could be much worse. And so, or climate action is never a lost case.
There seems to be uncertainty about whether we reach tipping points or which ones lay ahead. How is that?
The bad thing about these tipping points is that these changes are happening the first time, or the first time that we can observe it. And we just can estimate what will happen and what consequences this will cause. Like when the permafrost soil melts, then methane is released, and we still don't know how much methane exactly is stored in these soils. Yeah, it's very hard to predict what happens if one tipping point is crossed.
Mm-hmm.
And what we can observe is that there are several tipping points changing very fast. So the permafrost is melting much faster than everyone had expected. The melting rates in Antarctica are much, much faster than everyone had expected. And the rainforest is cut down and burned down much faster than we wanted.
Yeah. So also faster than you assumed when, well, not you, but the field, like climate science field, when they make their models, right? So they have predictions based on assumptions, obviously, and if the assumptions are worse, then the outcomes are worse, right?
Yeah. There was one example of some scientists measuring the depth of the thawing of the permafrost. And they said the depth was expected for the year 2090 or something. And they observed it today. So, so the predictions are, or we observe what we had predicted for the next 80 years or something.
Mm-hmm.
This is crazy. And it's also crazy that due to COVID-19, we all know now what exponential growth means. We all know the curves. Yeah.
Right.
And the crazy thing is that the changes in the tipping points seem to be exponentially.
So everything is much worse than it seems. That's basically the lesson from exponential curves. Everything is worse than it looks. So your answer is you don't know.
Yes. I think we can tell afterwards if and maybe when we crossed them. Mm-hmm. So some researchers argue that the tipping point in Western Antarctica is already crossed, maybe was already crossed in the 90s. And there's no consensus about if the whole West Antarctic ice sheet will melt completely or not. But most of the scientists say, yes, a big amount of this ice sheet will definitely melt in future. At the end, it's just a question of the definition. And although we cannot predict certain numbers or timing of events or something, we can say what the direction is.
And the direction is towards catastrophe. Now, to avoid catastrophe, countries around the globe agreed to limit heating of the climate to 1.5 degrees total. It was calculated at which concentration of CO2 in the atmosphere we would reach these 1.5 degrees. And based on this number, the so-called carbon budget was found, the amount of additional greenhouse gas that we can emit before we reach the 1.5 degrees. And it's much less than you'd think.
So the carbon budget, which was calculated by the IPCC, will be used up within the next 8 years. The carbon budget, and if you consider that the temperature is rising in the same relation to this, we will have 1.5 degrees in 2028. And if you look on the temperature rise within the last 5 years, we are very close to this. In the last 5 years, the warming went exactly the way it was predicted. So it was very, very fast. We had a rise of 0.2 degrees, which means from today to 1.5 degrees, we just need 0.3 degrees, which would be about 7.5 years. And this is exactly what it is calculated as the carbon budget, which is left over. So the 2 degrees, sticking to the business as usual, we will reach within the next 30 years.
I had been under the impression that the heating would happen with a delay, so I thought once we used up the budget, the temperature rise of 1.5 degrees could not be stopped, but it would happen over several decades. I got confused because the Paris Agreement sets goals for 2100. So no, we aren't talking about a slow warming at all. We are talking about rapid heating. In 2050, I will be 71, and given my demographic and lifestyle, I will have a 50% chance to live for another 10 years then. In fact, most of humanity alive today will live to see 2050, and it might not turn out pretty. But back to the Paris Agreement. The goal was to stay below 2 degrees by 2100, which we'll hit by 2050 if we don't act swiftly. And the actual target was 1.5 degrees, and because of continued growth in carbon emissions, we may hit that target within the next 8 years. That sounds impossible to me, to stop carbon emissions within 8 years.
Yes, and also to stop it in a way that everyone can keep on living. Yeah,
exactly. Yeah.
Because also, if we don't want it, we emit carbon dioxide.
Yeah.
Yeah, so I don't think that we can stick to the 1.5 degree, and I also don't think that we can stick to the 2 degree goal. And if you look at the predictions of the IPCC report, they have worst case and best case scenarios. And the best case scenario includes carbon capture technologies and all the stuff, and rapid action and very sustainable action so that everybody is benefiting from it. And even with the best case projections, we will hit the 2 degree during this century. And then we can maybe stop at this level. And then in the next century, it could decline. But this means that every day must be a climate action day. Yeah.
Right.
So we have to do our best every day up to the next century. So we have to be the best humans in the world every day. Yeah. And for the worst case, which is our current situation right now, it is between 3 and 5 degrees.
Wow, 3 and 5 degrees.
For the year 2100. And let's wait for the next report. Maybe it's more then.
Humans on their best behavior for decades. What could possibly go wrong? But a temperature rise of about 4 degrees also sounded familiar. That happened before.
From the last ice age to our pre-industrial era, so over the last 20,000 years, we had a temperature rise of more or less 4 degrees. And this also included a rise of sea level of 120 meters.
We call it the Ice Age here using popular language, but in strictly scientific terms, we are talking about the last glacial period, which had its peak about 22,000 years ago and preceded the current interglacial period. Ice ages, however, span much larger times and are defined by permanent ice somewhere on the planet. So technically, Earth has been in an ice age for 2.58 million years, the age being called the Quaternary glaciation. Within this period, we see cycles of cooling and warming, leading to glacial periods and interglacial periods. Wishful thinking leads denialists to argue that because during most of the planet's history Earth was much hotter than today, for example, it was 10 degrees hotter during the time of the dinosaurs, a hotter climate couldn't be that bad. But humans never experienced average global temperatures as high as we are moving towards. The genus Homo had hardly even emerged when the Quaternary period began. We only developed civilizations with agriculture, cities, and trade within this interglacial period, taking advantage of an unusually stable climate over the last 10,000 years or so. Most importantly, however, it's not the heat alone that is dangerous, but the speed of temperature change that is leaving us and most of the rest of multicellular species too little time to adapt. And this loss in biodiversity and the increasing number and intensity of droughts and extreme weather events that come with a heating planet are already leading to crop decline, threatening our food and water supplies globally. And the amount of greenhouse gas in the atmosphere is further worrying.
Concentration of carbon dioxide never exceeded, I don't know, maybe 300 ppm. So ppm is the unit. And today we are about 417 ppm. So the natural change between cold and warm ages and also the carbon dioxide concentration in the atmosphere between cold and warm, we changed it. It's far away from the natural concentrations of the past.
Understanding this, Elena began her outreach with Scientists for Future.
I started science communication in October 2018. At the same time, Greta Thunberg appeared in the media.
When Greta Thunberg and Fridays for Future were publicly attacked for their activism, Elena empathized.
When I was a teenager, I exactly felt what she was expressing in her speeches. And when Scientists for Future came up, I was very thankful, because if you can ask somebody if all this, what they tell you, is true, then it's the scientists. I got involved in our local group. My role was mainly to give presentations in science slams, but also a few presentations on a festival or a school or something, and then always in connection with Scientists for Future. If I do a science slam, I have the attention of the people for 10 minutes. I think it's my duty as a climate scientist and as someone who understands what is written down in the IPCC report and understands what consequences this is having. It is my duty to tell the people this. And I think the Science Slam is a perfect stage for this, because there are always other Science Slammers who have more jokes in their presentations. So the evening is not completely sad. Yeah. And I can also present my work, my scientific work, but also tell the people how urgent this problem is. Yeah.
Right.
I really hope that the people go home and the next day when they go to work, they might talk to their colleagues about this and that it might spread a little bit.
Elena points out that the combination of activism by Fridays for Future and the work of Scientists for Future is demonstrating to politicians that they are under close supervision.
I was really proud that Fridays for Future and Scientists for Future were working together, for example, to tell the government what they should do within 2019 to show that they would stick to the Paris Agreement goal or something. So they had very concrete arguments and tasks for the government to do. And this is very important because at the end of the year, you can measure if the task was solved or not. And then you have an argument like, yes, the government is really failing to do this. So, and this was also everything based on science. Yeah, so I was very glad that the politicians cannot say anymore like, yeah, we did something, because then it's written down and you can measure it. They definitely did nothing or not enough. And this is, I hope that this is also changing the way the people, for example, elect the politicians.
Mm-hmm.
Yeah, so how they vote and something, because now you can say they broke their promises. Yeah.
Given the drastic changes, especially the industrialized world needs to undergo, Elena finds it hard to imagine that the carbon emission trends can be reversed, mostly because it means that the people in rich countries must change their lifestyles.
A carbon neutral world or a carbon balanced civilization is definitely based on a low carbon emission lifestyle. And this also means that we don't fly, for example, or we only fly if it's really, really necessary, or we only fly if we can afford to pay 10,000 euros for one flight, because this could be a reasonable price for the damage that we leave in the environment, maybe.
So it's a rich man's world.
Yes, of course. Yeah. And yeah, for example, blowing carbon dioxide in the atmosphere is like dumping trash. And for your trash that you dump at home, you have to pay amount of money every year.
Mm-hmm.
But the dumping carbon dioxide in the atmosphere is for free still. Or nowadays the price is extremely low, but as long as the price is not high enough, it will not work. The mechanism of please avoid your emissions because it's better for everybody.
But isn't it socially unjust if
Of
you do
course.
everything by price? Why not just say, no, we don't allow flying until there are new technologies that allow flight without carbon emissions or something like that?
Yeah, well, this would be another point. If you can avoid or if you don't emit carbon, you should also not pay for it. Yeah. No, I think the social thing is the point of perspective, because the richest 10% of the world population are emitting up around 90% of the carbon dioxide. So we are rich, we are very arrogant, and we are having a very carbon intensive lifestyle. And the consequences of this lifestyle mainly impact the people in the global south, the people in the poor countries, but also women and children. It is extremely unequal that the few rich people on the world fuck up the future of everybody, and especially of the poor ones. Telling the people like you have to pay 10,000 euros for a flight is a problem of the upper class. And even if we don't feel like it, you and me, we are part of the upper class if we look on the world population. So
right, that's what I was about to say. I mean, you're talking globally,
yeah,
whereas within Germany, let's say, you'll have lower class people, working class people, who go on vacation on a famous Spanish island once a year by plane.
but even here, if you look on Germany, on the poor people on Germany also cannot afford to fly.
Right.
So
they already can't afford to fly.
Yeah. And there are several studies about the fact that the carbon emissions grow with your income.
Mm-hmm.
So the carbon emissions of an unemployed person in Germany is far lower than someone who has a job and could afford to buy a solar panel or whatever. But instead of this, they buy a flight and fly anywhere. Mm-hmm. So even here within the country, the carbon emissions are linked to your income.
Mm-hmm.
If you raise the prices for flights, the people who couldn't afford flying before will also not fly, and only the middle part of the society who have to change their behavior from flying to not flying, they are pissed off.
But those are most people, right?
Yes. I think it's very important for us scientists to speak out clear that we cannot keep up this lifestyle if we want to keep up our future. So either we fuck up the planet completely by doing what we're doing every day, or we cut down our emissions extremely, which also means that everyone stops flying. And it's not just flying, but flying is the biggest change a private person can do.
Mm-hmm.
If you start to get a vegetarian, or if you start going by bike, the impact is not so big. But one flight can make such a big difference in your carbon budget. If you change your lifestyle because you are aware and you take responsibility, just calculate what effect your actions have.
We are in the worst timeline. The latest updates find that global temperatures are following the worst-case scenarios in the climate models. And even these models assumed business as usual, not that countries would actively increase the rate at which they are damaging the environment. As a result, we are going to miss the agreed-upon target of limiting temperature increase to 1.5 centigrade, probably by 2028. Every one of us would need to be on their best behavior for the rest of our lives while we transition to low-carbon emission transport, energy generation, and production. But even with this technology shift, we must cut overall consumption. While activists and scientists work to push governments to smart action, the best we can do on a personal level is to cut down on flights. Among the things that are in our individual control, air travel by far has the worst carbon footprint. Elena asks you to check the effectiveness of your own choices to reduce your carbon footprint. I myself found that moving from the USA to Portugal greatly reduced my carbon footprint, and moving back to Germany further did, because I live in a house powered by solar panels, I share a hybrid engine car, and most importantly, I don't take the airplane to visit my family once a year. One way to push people to fly less is by regulating ticket prices to include damages done by carbon emissions. But this has major social implications and brings us to issues of inequality. In absolute terms, members of societies in rich countries are rich compared to members of societies in poor countries. However, inequality is not perceived by people in absolute terms, but in relative terms. Raising the price of air travel doesn't affect the richest people in rich countries. They can afford to pay that. It affects the average person in a rich country. This means it increases the perceived wealth inequality between the rich and the poor within the rich countries. Wealth inequality, however, leads to unrest and can destabilize democracies. I wonder whether the willingness to adopt climate regulation is correlated with income inequality. Maybe what needs to be communicated more is that flying and other carbon-intensive lifestyle choices create costs that are paid by everybody, not just the consumer. We all pay the subsidies for fuel and tourism that make air travel affordable. We just don't see it on the bills. And we pay for adapting our infrastructure to the changing climate, the higher costs for food and clean water, and rising healthcare needs. The war in Syria can be traced back to droughts and famine, leading to civil unrest. And we pay for that, too. I hope that despite the sad news, you enjoyed this episode, and if you did, please share it with your friends. If you want to contact me with comments, questions, and suggestions, you can do so by email info@scienceforprogress.eu or on Twitter @sci4progress. Thank you very much for listening. Have a good day. Bye-bye.
I say bye-bye. Stay positive. Every little warming we can avoid will get us some time.